Okay, this is a continuation of section 8.3. We're doing problem number 10. And in this problem, you've been given angle B, angle C, and side B. So let's decide what arrangement of information that is by drawing it. So I'm going to label as I typically do. You can label any way you like, angles A, B, and C, and put the information that I've been given. So 18 for B, 66 for angle C, and side B, which would be across from angle B, 19. This will be side A, this will be side C. So you've been asked whether or not you can begin the problem with law of sines or law of cosines. This time they ask you to select, but we've actually been doing that in every problem in this section. I keep pointing out to you why we've been forced to use law of cosines in all of the problems up until this point, at least to begin the problem. In this one, however, they've given you a choice, and they're asking you to just make recognition of which one you have the ability to start with. And I keep pointing out, as I have in all these problems, that if you have a complete pair, in other words, an angle and a side across from it, that's what allows you to start the problem with law of sines. So in this particular problem, I'm going to go after this C pair as the next pair that I complete, and I'm missing a side, so I'm going to put sides on top, and then the angle that's across from it. So side C, which is across from, so I'll be taking the sine of that, and then I'll make one other fraction, and that'll be this complete pair right here, where I have a side of 19 and the sine of 18 degrees. I'm going to cross multiply, in other words, swing that sine of 66 degrees right up into the numerator so that it is no longer here, and you have isolated C at that point and only need to put it in your calculator. Okay, so putting this in the calculator, it'll be 19 times sine of 66. My mode is in degrees. That's my numerator, divided by sine of 18. And I get 56. They've asked you to round side lengths to the nearest hundredths place. So that would be 56.17. Okay, so now we continue, and in this problem, after I have found this, I can also find the missing angle very easily. I can find this angle right here, which would be 180. And you could have even done this first if you wanted to. 180 minus 66 minus 18. In other words, you're just subtracting off the two angles that we already were given, just as we have in many of these problems. You're always doing that at some point in the problem. So take off the 66, take off the 18, and you have 96 degrees left. They asked you to round it to the nearest whole number, so 96 degrees left for angle A. Then if you want to do side A, then you can go back to law of sines. You can go side A over the sine of 96 degrees, and then you can choose any other pair that you want because we have all complete pairs at this point. I'm going to use the B pair, so I'm going to use 19, we're doing sides at the top, over sine of 18 degrees. Okay, I'm going to cross multiply this sine of 96 right. That gets it out of the denominator and allows you to isolate for side A. Okay, so now actually putting this in the calculator, we have 19 times sine of 96 degrees. That gives me my numerator divided by sine of 18. And that gives me 61 0.14. They ask you to round to the hundredths place. Okay, those are the three answers that I found. I found side C first, and then I went and found the missing angle of 96 degrees, and then I finished it off by finding side A. Okay, moving to problem number 11. Okay, so in problem number 11, I've got this glare from the sun going on here. Okay, so in problem number 11, they give you A is equal to 26 degrees, A is equal to 9, and B is equal to 10. So let's draw this to see what kind of arrangement we have here. Again, I'm just going to label A, B, and C. I'm going to put 26 for A, which was given. Across from angle A is side A, and then across from angle B is side B, which was given as a 10. Okay, notice here that you have side, non-included angle. This would have been the included angle. That would have been side, angle side, had you been given angle C, which would have allowed you to start with law cosines. However, whenever you are given side, non-included angle, this is the ambiguous case, and you can start it with law of sines, just because you have a complete pair. You have side A and angle A. But of the law of sines cases, which this qualifies as one of those cases, because you have a complete pair across from each other, but it does happen to be the ambiguous cases, meaning it is possible that this triangle can be drawn one and only one way, which would classify it as the one solution case. It's possible that the triangle can be drawn in two different ways. That's called the two solution case, and that means you would have two complete sets of solutions, one for each triangle. Or it is possible that when you go to find your very first solution, you'll discover that this triangle really doesn't even exist because the sides are not adequate to come together at the vertices. So let's see what happens when we go to find our very first angle. Now, of course, we're going to go after this B pair right here only because you have part of it. You have the side, you need the angle that comes across from it, that is across from it. So I'm going to go after B first. So I'm going to go sine of angle B. Remember that I told you that whatever you're finding, you should put that in the numerator. Sine of angle B across from the 10, and then sine of 26 across from the 9. And if I cross multiply this 10 right into the numerator, then it is no longer here, and sine of B is isolated, the unknown. So now let me get a decimal for all of this. That'll be sine of 26 degrees times 10 in my numerator divided by 9. So I have 0.48708 approximately, although I'm really to even get a more exact answer. Okay, so I'm looking for angle B, and whenever I'm looking for an angle, you have to switch the angle and the decimal so that you are now looking at an inverse statement and can get your calculator to find that angle for you. Okay, so now putting this in the calculator, I'm up in that decimal by typing in second answer, and that gets me 29 degrees. Now let's see, for this problem it says trying to see what they want you to round to. Okay, round to 2, select the fill in the round to 2 decimal places as needed. Okay, So this would be 29.15 degrees. Okay, so with regard to this ambiguous case that we're faced with in this problem, only because we were given side, side with an angle that was not included between the sides. So because we're in the ambiguous case, at the moment that you find your very first angle, you need to figure out whether this might split into two different triangles. So we know that this can be 29.15 degrees, but could it have been something else? In order to entertain that possibility, you're going to come off to the side and you're going to go 180 minus what you know it can possibly be in order to say, is there another possibility? For angle B. Because if there is, you have to draw another triangle and do two sets of answers. So let's see. If I was to go 180 minus 29.15, 180 minus 29.15, that would be 150.85. This could possibly be 150.85, but only if that 150.85 doesn't throw you over the 180 degree limit that exist for all triangles. So think about it. Just roughly add these up. 150. Let's imagine that it was 150 rather than the 29. Not that we're going to do all the solutions as though it's a 29, but there might be a whole nother triangle that we need for, but allowing this angle to be 150, and it is okay because 150 plus the 26 that you have here is only approximately it's a little bit over 176, 176.85. That means you still have room to give some amount of degrees to angle C. Therefore, another triangle can be drawn. Everything that was given, you're going to leave the same. Like this was given, you're going to leave that the same. The only thing that's going to change is this angle that could go by two different possibilities. It could be the original one that we found at 29.15 degrees, but we found out by coming off to the side and subtracting 29.15 from 180 that it can also be 150.85. So in our other triangle that we're going to draw, this will be 150.85. We already figured out that that is a possibility because those two angles don't throw you over the 180 degree limit. So two different possibilities for angle B, 29.15 and all of the answers associated with that. We haven't finished the answers yet for that case. And there's also the case where B can be 150.85. Let's go ahead and put all the rest of the given information on this new triangle. So B was 10, and it's always going to be 10. A is 9, that's always going to be 9. The only thing that's going to change is the 150 and the answers that will be associated to this 150. Here we're going to get all answers associated with the fact that angle B is 29. Okay, let's continue. So continuing to find, let's see if I can make some room here to complete this first triangle. Okay, so let's see. Why don't we go after, to finish this triangle off, we'll go after angle C. So here's angle C, which is 180 minus these two angles put together. So take off the 20, you can take them off one at a time, and also take off the 29.15. And then you will have angle C is 124.85. Okay, so based on this angle being 29.15, this angle comes out to be 124.85. Okay, so you have that answer, you have this answer, and the only thing that we haven't found to complete the solutions for this triangle is side C. So I'm going to find that next. I'm going to go side C. I'm going to switch over to law of sines. I'm going to go side C across from this 124.85 degree angle. And then I'll do one other fraction, and I can use any information I want. I can use the B pair, I can use the A pair. I'm going to use the A pair. Just going to go sine of 26, and the side that's across from that is a 9. Then you're going to cross and multiply this up here. I'm kind of running out of room here, so I'm just going to go ahead and give the final answer for side C, which will be 9. This is going to come right up here like we have been doing in every problem. So it'll be 9 times sine of 124.85, then divided by sine of 26. Okay, 9, and that's divided by sine of 26. And I got 16.85. Okay, that was 9 times sine of 124.85, and then finally divided by sine of 26. Okay, moving on to this other triangle, where the only thing that's different is angle B rather than 25. So all these, the two other answers that remain are going to change. First thing we'll do, we'll find angle. Angle C will just be 180 minus the 26 minus the 150.85. We're just subtracting off the other two angles. This will be 180 minus 26 minus 150.85. And that gives you 3.15 for angle C. 3.15 degrees. I didn't see anything else in the instructions here other than it said round to 2 decimal places as needed. Okay, and then finding side C across from angle C, which happens to be 3.15 degrees. And of course, for that last side, you can use law of sines. So I'm going to go, let's see, I'm looking for side C. That is across from an angle that's 3.15 degrees. So I'll go sine of 3.15 degrees. And then I'll set it equal to one other fraction. The other fraction I'm going to use is the A pair. So sine of a 26 degree angle across from 9. And then you're going to just swing this right up here. Like I said, I'm running out of real estate here. So I am going to just put that here, that's going to go up here, and go ahead and put it in the calculator. So it'll be 9 times sine of 3.15. And then finally divided by, and maybe I have room here to write it. This is what I'm sticking in the calculator. The sine of 3.15 would be up there in the numerator, trying to mix the words together. And then finally the denominator will be sine of 26. So that will be 9 times sine divided by sine of 26 degrees, and that would be 1.13. Okay, so we found side C and angle C based on 150.85 degree angle B, and here we found angle C and side C based on a 29.15 degree angle. So this is called the two solution case, which for number 11 would be, there's only one possible choice, B right here, and then you just fill in all the answers. So when it says A1, what was angle 1, side A1 and side C1? That means from the original triangle. Oops, I'm putting the answer in the wrong one. 11 is where we're supposed to be answering this. Okay, so that was side B, and then you go and put all these answers right here. Okay, so we found this in the original triangle was 29.15. We then found angle C, and angle C in that problem was 16. Well, side C was 16.85, and angle C in that problem turned out to be 124.85. Just put the answers where they belong. Okay, this is angle because it's bigger than that. Then in the second triangle that we drew, where we had a different angle B, that one was 150.85 because this was the two possible solution case. Angle C turned out to be 3.15. And the side across from it turned out to be 1.13. Okay, that takes us to problem number 12. And I'm going to do this on my own paper. We have side B, side C, and angle A. Just to give me a little bit more room. Okay, so this will be problem number 12. Problem number 12, we have B is equal to 2, C is equal to 10, side C, and then we have angle A equal to 52. Let's see by drawing the picture what kind of arrangement we have. So start by labeling a triangle ABC, putting what they've given you where it belongs. Okay, now this is side, angle, side. And side, angle, side means that you start with cosines. Another way to think about this is, as I keep pointing out, you don't have anywhere in this problem an angle and a side across from it, because only then can you start the problem with law signs. Not that we're not going to jump into law signs after we find the first answer, as you saw how I did every problem leading up to number 9 before we began making a decision. You're always making a decision now. Again, if you don't have a complete pair, an angle and a side across from it, you're not starting with law signs, you're starting with law cosines. Okay, so let's get started with this. We know that we want this angle to be in it, so side A is also going to be in one of the 3 theorems that we choose, the definitions that we choose for law cosine. So it'll start off with side A squared, and then this will be the B squared and the C squared. And then that theorem goes on to go -2 times these two sides, the 2 and the 10, but in their linear form, not their quadratic form, times the cosine of the angle that's across from this side that we're looking for, which is 52 degrees. Okay, so only one unknown here. Everything on the right side is just pure numbers. So we can put all of that into the calculator all at one time. Okay, so in this problem, it is 2 squared, let me try turning it on, 2 squared plus 10 squared minus 2 times 10 times cosine of 52. Okay, and 9, we'll just leave that in the calculator. That is just a squared. We haven't gotten a yet. I'll just write 0.3735. It's kind of an approximation, and then you know to actually get a, we have to take the square root of this. Take the square root of both sides in order to get A. Okay, so second square root, second answer, close that up, and it is 8.9. Let me see what they want you to round here. It says, if necessary, fill in the answer box to complete your choice. Do not round to the final answer, and then round to 1 decimal place as needed. Okay, now again, this can't be the ambiguous case. That's only for when you're given 2 sides and a non-included angle. This is side, included angle, another side. That's called side, angle, side. So you don't have, there's no possibility that this can be anything other than, that it can be drawn any way other than the way that it is drawn. Let me write this. This was 8.9. So I'm going to go ahead and put that there for A. And I'm going to continue with this. This is 8.9. But anyway, at this point, you do have a complete pair. You have an angle and a side across from it. So even though I started with law of cosines, I can now switch over to law of sines. But that was the case in all the problems where you started with law of sines. So now I'm going to go after the next biggest angle. I'm going to go with this smaller side, which will give me the smaller angle, and then I'll go after the bigger one last. Okay, so here we go. I'm looking for an angle, so I'm going to go sine of angle B. I'm going after the next biggest angle first. Next biggest angle will be across from the next biggest side. So this will be 2. And then you can use this complete pair that you have. So sine of 52 across from 8.9. Then you can isolate the expression that has the unknown by swinging this 2 right up into the numerator and putting all of that in the calculator. So this will be sine of 52 times 2. That's in the numerator, divided by 8.9. So this is 0.17708, but we want to get angle B, so we need to do the inverse of that decimal. So it's second inverse, dump in that answer, and we get 10.2. So angle B is approximately equal to 10.2 degrees. So there's another one of our answers. And then by the time you've used law of cosines, which is the most amount of work, then switched over to law of sines, which is a little bit less work because you're just using proportions rather than all this squaring and taking square roots and so forth. And then finally to finish it, so this was step 1, this was step 2, and then to finish it, even easier. All you have to do is go 1/8 minus the 2 angles that we already know, and we have that final remaining answer. So 180 minus 52 minus the 10.2 that we have, and that is 117, and that will be angle C. All of this was to figure out angle C. So angle C is 117.8. And notice, should get used to checking this, that biggest angle is across from the biggest side. And then the medium angle is across from the medium side. And the smallest angle, 10.2, is across from the smallest side. That should always be the case when you go to do a little mini check on your answers. Okay, that completes problem number 12. So what we have left now is numbers 13 and 14. And let's see if we can get this all in one video, hopefully. Okay, so let's move on to problem number 13. This one doesn't look bad only because I read it already. It's pretty straightforward. Like, you know, a lot of these word problems have multiple steps before you get to them, but I can see from the question that this should be fairly easy. Golfer hits an errant tee shot that lands in the rough. A marker in the center of the fairway is 140 yards from the center. They've already marked that off from you, from the center of the green. While standing on the marker and facing the green, the golfer turns 125 degrees towards the ball. They've also placed that in the picture. He then paces off 50 yards. They mark that off. How far is the ball from the center of the green? This is the green right here. That's the center where the little flag is, and all they want to know is what is the distance from the center of the green to the ball. So very straightforward, just in one setup you're going to get that. You need to decide whether it's law of sines or law of cosines. So I don't think I'm going to be able to get it with law of sines because I don't have a side and an angle across from each other. So I'm going to have to start this with law of cosines. I know that I want to find this side, and all of the law of cosine definitions, formulas, they all start with a side. And then they finish with the angle that's across from that side. So that'll be perfect for us. So I'm going to go x squared is equal to the other two sides squared, which were 140 and 50, minus 2 times each of these sides, the 140 and the 50, finishing off with cosine of the angle that's across from the side I'm looking for, which is the 125. Okay, so we're going to do x squared is equal to, we're going to get this whole calculation done in the calculator. So that'll be 140 squared plus 50 squared minus 2 times 140 times 50 times cosine of 125 degrees. Put all that in. It's 3130.07. To get x, of course, you're going to have to take the square root here and the square root here. So now this is x is approximately, and they want you to round to 1 decimal place. So this will be second square root. Dump in that answer by typing in second answer, and it is 173.6. And that's the answer for problem number 13. Okay, moving to problem number 14, last one. And this is in yards, or units on this particular problem. Okay, in number 14 it says a cruise ship maintains a speed of 20 knots. So that's 20 nautical miles per hour. You can just write 20 miles per hour when you're doing the conversions that are required in this problem. In order to go from San Juan to Barbados, a distance of 600 miles. However, instead of going straight from San Juan to Barbados, that was not possible because all these storms were happening. So the ship had to veer 38 degrees. It had to turn 38 degrees and head out on a path that was not directly to Barbados. So it turned 38 degrees. It's headed down this path. They give us some information about that. To avoid a storm, captain heads out of San Juan at a direction of 38 degrees off a direct heading to Barbados. The captain maintains a 20 knot speed, 20 miles per hour. They just explained that up here for 14 hours. So what they're giving you by mentioning this right here, that he heads off going this way at 20 miles per hour, this distance right here. Okay, so if you want to know what this distance is, you can just do a conversion. You can go, we'll just call this D, from here to where this little boat is shown will be just like this. He's traveling at 20 nautical miles per hour. That's the speed. Times for 14 hours. This hours cancels with this, and the distance that he is traveling, moving at this speed, 20 miles per hour for 14 hours, the distance that he manages to travel in that amount of time would be 20 times 14. So 280 miles. Okay, that is this right here. Okay, then the question asks, after which time the path to Barbados becomes clear of storms, through what angle should the captain turn to head directly to Barbados? So he gets here, he sees that the path is clear, and he wants to turn to go directly to Barbados instead of continuing on this path. So basically they want to know this angle right in here. I know that probably confused you, but we're looking for this angle right here. I guess I'll call it X degrees. Okay, so in the next part of this problem, should head through what angle? Let's see. Now, if we tried to look for this angle, we can't start this with law of sines because we don't have an angle and the side across from it. We know the 600, but not this angle. We're looking for this angle. We do have this 38 is really in here. Okay, maybe I should make this picture bigger. So this is 38 degrees. This is 600 miles. We found out that this was 280 miles. Okay, so the boat is traveling this far for 280 miles, and then all of a sudden it wants to turn to go to Barbados because it sees that the path is clear. I want to know what is this angle right there. And then there's going to be another question that you're going to ask as well. So that they're going to ask also. Okay, so let's see. If I wanted to find this angle right here, I could start with law of cosines. Okay, I could go 600. We got the X there, so I could go start it off with 600. And then I'll be finishing it off with this angle right here. Oops, no, wait, let me take that back. I don't have enough information actually to start it that way. So what I'm going to have to do is this first. I see that I'm blocked from doing that, which I'm blocked because I have two unknowns. I was starting to find it like that, and then I saw that there was going to be two unknowns in this particular equation. And I guess I should just write that anyway. I was writing this. I was going 600 squared is equal to, and then I needed two other sides here. And I did have a 280. I could have went like that. But then when I went to go get the other side, that's not known either. So that means I need to find this side. Call it whatever you want, but I'm kind of blocked from doing this. So let me try something else. I'm going to find, I thought that maybe I could go after this angle first, but when I tried to begin writing it out, I was going to have the angle that was unknown. That would have been all the way down here at the end. And I also didn't have this other side that I needed. So Now I'm going to say, okay, instead of going directly, and this is what I mean by a multi-step problem. You want to go after something right away in the very first step, but you sometimes don't have enough information to do so. So I'm going to find side Y first, this missing side right here, the distance from where the boat turned and went this way, and then I can go after this angle. Okay, so if I'm going to do this, I could use, let's see what we have here. If I did law of sines, I could do sine of 38 over y. And then what other side could I use? Nope, I can't, because I can't use law of sines. Why can't you use law of sines? Because you don't have a side and an angle across from it. So, since I can't use law of sines, notice that this pair that I was going after and suggesting, oh, can I use law of sines? It's not complete. I'm missing this, but I have the angle. So, let's do law of cosines. And much of this section has been about you making decisions about how you can start. If you have more than one thing that's unknown in any formula that you decide to use, then you can't start with that. So if I was to start with law of cosines, which starts with sides, it would be y squared is equal to the other two side squares, and it appears that this is going to work. You go like that, then it would go minus 2 times 600 times 280, finished off by the cosine of the angle that's across from this side. That's how law of cosines works. So we're going to get y squared. Let's go ahead and put all these numbers in. So notice that what I've chosen this time only has one unknown, and that should always be the case. So this is 600 squared plus 280 squared minus 2 times 600 times 280 times cosine of 38 degrees. Okay, that comes out to be 173628. Just write it here to have something, even though I'm keeping the entire thing in my calculator. And then if you want y, you have to take the square root. So this is y is approximately second square root, second, dump that answer in. 416, round to 1 decimal place for the angle, 1 decimal place for this. Okay. So right now, since I'm in the middle of the problem and neither one of these is the questions that they're asking, they want to know the captain should head through an angle of what? They want to know that angle right there. And I'm not answering that yet. I haven't gotten to that yet. And they also want to know the time it will take for the ship to reach Barbados after it turns right here. After that little ship turns right there, how long will it take to get there? So, since this answer is in the middle of the problem, I'm just going to hold on to a lot of the decimal places. Okay. So I'm going to put this right here, 416.6874. Okay. Then, after I do this, I could go after that angle that they are looking for in part A, because now I have a complete pair, so I can use law of sines, and then I can finish off this pair, the 600 and the x. So now in step 2, I'm going to switch to law of sines. Okay, that'll give me, let's see, I'm going to use sine of the unknown angle, which is across from 600, and then I'm going to do sine of 38 degrees, angles on the top, and that's across from the 416.6874. that I just found, which if I hadn't have found that, even though it's not one of the questions that they're asking, if I hadn't found that, I wouldn't be able to go on and answer the questions that they are asking. Okay, so this is 4.6874. Oops, got a number wrong there. Okay, cross multiply, swing that 600 right up here so that it's no longer here, and you will then have sine of some unknown angle is equal to the decimal that we're going to get right now. So sine of 38 times 600 divided by 416.6864, and that is 0.8865. Okay, then if you want to find any kind of an angle, you're going to have to inverse by switching the angle and the decimal. So this will be second inverse sine, dump in the answer, and you get 62.4 degrees. And that is for this angle right there. So that would be 62.4 degrees for that first answer right there. It has to turn right here and through an angle of 62.4 degrees and then head down this path 416.6874. Second question is, how long will it take to get from here to Barbados? Barbados is right there. So in part B, this was part A that I just answered. So in step 3, and to answer part B, I can take the 416.6874, that distance in miles that I know you have to travel once it turns. It's still moving at the same pace at 20 nautical miles per hour. I'm going to go 20 miles to make the miles cancel out. I'm going to put it on the bottom. Per hour. So in order to get that second answer, it would just be top times top divided by bottom. And that will be 20.8. Miles is gone, and you're in hours now. And that would be the answer for part B. Okay, that concludes section 8.3. And we'll continue in the next video with section 8.4.